Hello dear students, I am Prabodh. In the previous class, I asked you this question about this graph, that whether this graph shows acceleration, uniformly acceleration, deceleration, or which type of graph is it. As you can see that this is velocity and this is time. When the time increases with respect to the increase of time, the velocity here decreases. Here at certain point, this point, that velocity is more compared to this point, compared to this point, compared to this point. So the velocity gradually decreases. So whenever a body is moving with certain speed and a brake is applied, the velocity of the body with respect to time decreases. So this is the graph of deceleration. Okay. Now this is velocity time graph. This one I have explained yesterday. Now there are some questions and today we are going to solve those questions. What is the nature of distance time graph for uniform and non-uniform motion of an object? So this question you try, I think you must have tried it on your own. So what is the nature of distance time graph for uniform and non-uniform motion of an object? To understand this one, see what is distance time graph. If I draw a diagram here, this is distance, this is time. Okay. Now in case of uniform motion, it will be a straight line, that is equal distance travel in equal interval of time. In case of non-uniform motion, it will be a curve one, any type of curve, okay, that is unequal distance is covered in equal interval of time. Okay. So this is the nature. That means it is a straight line, this is a curved line. Okay. Second question, what can you say about the motion of an object whose distance time graph is straight in parallel to time axis? So what it is trying to tell you, that if, let me draw a diagram, bigger diagram here. Suppose this is a distance time graph, this one is distance, this is the time. Let us come back to the question again. What it is trying to tell, that what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis. Now the line is parallel to time axis. Here if I choose a line here, this line is parallel to x-axis. So what can you say about this? So here, see, here distance remains constant as time is increasing. Time is increasing here, see, the time is increasing, but distance remains constant here. The distance between this region, this region, this region, all the region, the distance remains constant here. That means the body is at rest position. That means suppose this is a point A, this is a point B. The body will start its motion from point A and it will reach to its destination, point B. At point B, it is at rest position. Now, with respect to time, when time passes, the body will still at point B. So, time is going through, but the displacement or the distance of the body is not changing. So, that is the case. Okay, I hope you understood this one. Third one, what can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? So now we are talking about speed time graph. So here let me draw another graph. This is speed time graph. This one is speed. This is time. This is the graph. So what is the question? What can you say about the motion of an object if its speed time graph is a straight line parallel to the x-axis? Now, similarly, if the speed time graph, if here it is parallel to x-axis, what can you say about it? Now, see here time is increasing, but velocity remains constant. At this point, the velocity remains constant. So, the body is moving at uniform velocity. Suppose here velocity is suppose 40 kilometer per hour. That means the body is moving exactly at 40 kilometer per hour irrespective of the time. If the time is increasing, also the body is moving with same speed or same velocity. Okay. Now, next one, what is the quantity which is measured by the area occupied by the velocity time graph? This one I have explained you yesterday. Okay, you give this answer on your own. If area is occupied by the by the velocity time graph, what is that area? I have explained you and I did some calculation here. Okay, and I also showed you. Okay, now equation for velocity time relation. So today we will start this one. Equation for velocity time relation. Okay, how can you find out the equation? See, this is a graph. This is velocity, as you can see here. This is time. The body has started its motion at this point, or we have considered this point A as initial point, okay, and B as final point. Now you can see that we generally consider the motion of the body from this point, whether it is uniform or non-uniform. If it is uniform, the line will be like this, straight line. If it is non-uniform, then it may be any curve. Okay, but here now we have considered the velocity time graph from this point. What is the region of this? So let me explain you this one first. Now see, this is x-axis, that is time axis. This is y-axis, that is velocity. Here we are going to draw the velocity time graph, where the graph we showed was like this, as you can see it from here. See, this is point A. So let me first name these points O, A, E, B, D, C. Okay. This is C. This one is D. O, A, B, O, A, E, B, D, C. Okay. So these blue lines are imaginary lines. The blue lines does not exist. These blue lines are imaginary lines. Now see, as we are considering this one as initial point, it has certain velocity. Okay. Now it comes to certain point having certain final velocity. That means suppose this is point A. From point A, the body is moving to point B. Okay, this is point A, this is point B. So the body has not started its motion from point A. Before point A, there is certain point, there is another point which may be K, M, N. So let us consider this point be M. Before point A, there is another point M. From this point, body has started its motion, started its journey, and finally it will reach to point B. But we have considered between these 2 points this length. We have considered this point as initial point and this point as final point. That is why at this point the body is having certain velocity. Okay, that is why we have drawn the graph from this point A, rather doing this, taking this as initial point. Okay, I hope you could understand this one, that what is the region that we have taken this graph from this point. Now before our calculation, before our so now before equation for velocity time relation with the help of this graph, I want to make you understand something, that there are 3 types of relation. between velocity, acceleration, time and displacement traveled by the body. So here we consider, let us u is initial velocity of the body, v is final velocity of the body, t is time taken by the body to reach certain point, s is the displacement traveled by the body, and a is the acceleration of the body. So these 5 terms you should always keep in mind. So there are 3 types of relation possible between these 5 different terms. So what is the first relation? The first relation is v is equal to u plus a into t. We are going to prove this one, don't worry. Second one is s is equal to u into t plus half a t square. Okay, v equal to u plus a t, s equal to ut plus half a t square. Third one is equal to v square minus u square is equal to 2 a s. Okay, so these are the 3 relations that we are going to prove with the help of the graph. You should keep this one in mind. Okay, you should always remember these 3. So here we are going to prove the first relation, that is v is equal to u plus a into t. Okay, this one we are going to prove here, first one. Okay. Now you can see that BC can be written as BD plus DC. Okay, now let me line it. So BC can be written as BD plus DC. Okay, now as these two are parallel line, BD will be equal to EA, DC will be equal to OA. Okay, so BD can be written as EA and DC can be written as OA. Okay, EA plus OA. What is BC here? What is at point B? At point B, the velocity of the body is final velocity. So in place of BC, we can write V. So as BC at point B, it is having final velocity, which is replaced by V. Now OA is initial velocity. OA is initial velocity, that is U. So it can also be written as EA is equal to V minus U. Now, as you know that acceleration of the body, acceleration is nothing but the change in velocity divided by change in time. So here acceleration is equal to, what is change in velocity here? This is the initial final velocity BC, initial velocity is BD. So this is BD is the change in velocity, that is BD, change in velocity, divided by change in time, that is OC. Here I have directly taken OC as time because in this triangle, if you consider this triangle, BD is the change in velocity, AD is the change in time. Here AD and OC both are equal. So here I have written acceleration equal to change in velocity divided by change in time. Okay. Now in place of OC, the time t can be taken because we have considered OC as t. So here it will be BD divided by t, time t, or it can also be written as BD is equal to A t. Okay, now this t is in denominator, it will multiply with A. So BD is equal to A t. Okay, now if I again back to this point here, this point where EA is equal to V minus U, EA, what is EA? EA is nothing but BD, both are same. This is EA, this one is BD, both are same. So in place of EA, I can write BD. Okay, that means this equation, this one, this equation, and this equation, both are same. So here I can write that AT is equal to V minus U, or it can be written as V is equal to U plus A T. Okay, here we have proved this relation that V is equal to U plus AT. This relation has been proved. Okay, so there are two more relations, S equal to UT plus half a d square and V square equal to U square minus 2AS. Okay, S equal to UT plus half a d square and V square minus U square equal to 2AS. These two relations we are going to prove in the coming videos. So you watch this video again, try to understand the graphics of it, that how with the help of graph how we can prove it, and in the coming class we are going to prove S equal to UT plus half a d square and V square minus U square equal to 2AS. Okay, thank you and have a nice day.